Good afternoon. I'm Miss Mikesell, and this podcast is going to focus on solutions, specifically on how to find the molarity of a solution and do quantitative calculations. Our EQ for today's podcast is how can we quantitatively describe solutions? We describe solutions quantitatively in chemistry using molarity. Molarity is the way to measure the concentration of a solution. It is the number of moles of solute in 1 liter of the solution. It can be represented with the following equation. Capital M, which represents molarity, is equal to the moles of solute divided by the liters of solution. Couple of quick reminders. Please make sure that if you're not given moles, you use molar mass to convert to moles before you substitute in. And 1,000 milliliters is equivalent to 1 liter. You will need to make sure that you get 2 liters as your volume unit before you can substitute. So molarity simply describes the number of moles of solute present in 1 liter of solution. For example, a 4 molar solution is a solution that contains 4 moles of solute in 1 liter of the solution volume. As we start our calculations, remember if you're given grams, you'll need to use the molar mass of the compound to convert to moles before you substitute. And if you're given milliliters, you'll need to convert to liters, remembering that there is 1,000 milliliters in 1 liters to make that conversion. We'll use the guess method to solve our problems. G means identify givens, U, the unknown, E is rearrange the equation, S is substitute our values and solve, and S is to round for significant figures. So let's record our first problem on your paper and try it out. What's the molarity of a 125 milliliter solution that contains 0.875 moles of solute? Let's start by identifying our givens. We know that the volume of the solution is 125 milliliters, and there's 0.875 moles of solute present. Thus, our unknown is molarity. That's what we're solving for. We already have our solute in the right unit of moles. We're going to need to make sure we convert milliliters into liters. Doing that, we're going to divide by 1,000 or move our decimal 3 places to the left, changing 125 milliliters into 0.125 liters. Now we need to check our equation. Our base equation for molarity is equal to moles divided by liters. We already have moles and liters, so we don't need to rearrange our equation and should be able to just substitute. As we substitute in, molarity is 0.875 moles divided by 0.125 liters, and we get an answer with 3 significant figures because our measurements had 3 sig figs of 7.00 molarity. We have a 7 molar solution. Let's try a second problem. You're given 25 milliliters of a 3 molar sodium hydroxide solution. How many grams of sodium hydroxide are present in the solution? Again, start by identifying your givens. So we know that we have 25 milliliters in volume and a 3 molar NaOH solution. Our molarity is 3.0. We need to solve for the number of moles of sodium hydroxide, and our volume is 25 milliliters, which we're going to convert to liters by moving the decimal 3 places to the left. Once we've identified our givens, we need to rearrange the equation to solve for moles. So our base equation is molarity is moles divided by liters. We'll multiply both sides by liters to remove it from the denominator of the equation and isolate moles. And our new equation will be moles is equal to liters times molarity. So we're going to multiply the volume times the molarity to solve for the number of moles. 0.025 liters times a 3 molar solution will give us 0.075 moles of sodium hydroxide. We're not quite done though, because we want to be able to measure that out in the laboratory to make our solution. We need to convert it to grams. So now we need to do a quick train track, starting with 0.075 moles of sodium hydroxide. Use the molar mass of sodium hydroxide, 40 grams, to convert to grams of sodium hydroxide needed. And our final answer, 3 grams of NaOH. All right, take a second and write down the third practice problem, and why don't you try it yourself? Let's see how you do. How many liters of a 2-molar calcium chloride solution would contain 55 grams of CaCl2, or calcium chloride? Start by identifying your givens. We should recognize that liters is our unknown, but that we know the molarity, 2.0, and the number of grams, 55. Since we don't know moles, we're going to have to do a quick molar mass conversion. 55 grams of calcium chloride, molar mass of calcium chloride is 110 grams for 1 mole of that same substance, to determine that we have 0.05 moles of calcium chloride. Now that we've converted our givens to the right units, we can substitute and solve. We need to rearrange the equation first, though, and this equation was tricky to rearrange. Remember that since molarity is moles over liters, and liters was in the denominator, you have to move it to the numerator before you can isolate it. So your final rearranged equation should be liters is equal to moles divided by molarity. Once we've rearranged the equation, we can now substitute and solve. Our volume is equal to moles, 0.05, divided by molarity, 2.0. I took the capital in molarity and changed it into moles per liter, which is what molarity represents, so we can see how units cancel. Since we have a fraction within a fraction, we're going to need to clear that by multiplying by the reciprocal. The reciprocal of moles over liters would be liters per mole. So liters per mole. Now we should be able to see that moles cancels out, and our answer will be volume, the liters of a solution. When I do the division, my answer should be 0.25 liters of calcium chloride. All right, one last problem. What mass of solute is needed to prepare 0.5 liters of a 0.5 molar solution of copper 2 chloride dihydrate, which is CuCl2 attached to 2 water molecules? Note, when you find the molar mass of this substance, it's the molar mass of all parts of this formula. So copper, chlorine, as well as the mass of 2 H2O molecules. Again, let's start by identifying our givens. So we know the molarity that we want, and we know the volume of the solution that we want to prepare. We're first going to need to solve for how many moles of copper 2 chloride we need as solute, and then convert that to grams so that we can measure it out. To solve for moles, we're going to need to rearrange the equation. Molarity is moles per liter. Let's multiply both sides by volume. Volume will cancel out over here. So to solve for moles, we're going to take the volume of the solution times its molarity. So we can substitute and solve. 0.5 liters times 0.5 molarity, we're going to need 0.25 moles of copper 2 chloride dihydrate. And now we need to convert to molar mass. Let's set up a quick train track. If we have 0.25 moles of the copper 2 chloride dihydrate, its molar mass is 170 grams because it's the mass of 1 copper, 2 chlorine, and 2 water molecules. So we will need a total of 42.5 grams of copper 2 chloride dihydrate. All right, let's end by looking at how a solution is made. This is something that you'll be doing in some future labs. Steps to making a solution. You start by weighing out the amount of solute that is needed using a balance. Once you've done that, you add it to the volumetric flask. Make sure you use distilled water to rinse the weigh boat and ensure all of the solute gets into the volumetric. Then you add some solvent to the volumetric and swirl to mix, making sure that the solute is fully dissolved. We use a volumetric flask because it's easy to swirl and not lose any of our solution that is present. It's specifically designed for the task so that we can get the solute to dissolve in. And then finally, we carefully fill up the volumetric to the line on the neck. There's a special line on the neck or a mark that tells us exactly where 500 milliliters is. Once we do that, we'll cap our volumetric flask at the top, and then we can invert it to mix to make sure that the solution is dissolved and uniformly mixed. So let's watch a quick video that shows that process step by step.
Using a balance, obtain the required amount of solid. A volumetric flask gives the most accurate volume measurement. Add in some of the water, add in the solid, stir and mix. Keep adding water and stirring until the correct volume of solution is reached. These simple steps will ensure that you always prepare accurate solutions.
Thanks for watching the podcast. I hope it was helpful. Have a great day.